Okay, so a friend had a question here. This is a Physics 1 problem talking about Newton's law of gravity. So should be kind of fun to go through. I'm going to help her with it, and hopefully it helps you guys as well. So the center of a moon of mass little m is a distance d from the center of a planet mass big M. At some distance x from the center of the planet, along a line connecting the center of the planet and moon, the net force on the object is 0. So let's draw a picture. I'm going to do a small little dot for little m, the mass of the moon. And then because I'm such a bad drawer, I'll use the shape helper there. And this will be big M. This is the mass of a planet. And we know the distance from here to here is a distance d. Yeah. But they tell us that at some point, I'm going to call this point here, a distance x from the planet, your net force is 0. It's probably going to be closer to the moon than the planet because the planet is going to have a stronger gravitational pull. And just so we set up our coordinates right, we're going to say the right is positive. I don't think it specifies, but we'll assume right is positive. Okay, so the only two forces, let's draw a free body diagram, acting on an object at that point is the pull from the planet, which I'll just say is Fg big M, and the gravitational pull, which it might not look equal, but it's supposed to, of the moon on this little object, right? And these two are going to be completely opposite. So let's look at this. What forces are acting on it? Well, on the right, we have the force of gravity from the planet, which, if we remember Newton's second law, or I'm sorry, his second law, his law of gravity, big G, big M, little m, over r squared, r hat. Don't worry about the r hat, but it is a vector. Well, for the one from the planet, it'll be G, big M. I'll call it m sub naught for the mass of the object, over the distance from that object to the center. Well, it says the distance is x, right? So that's just x squared. And that should be equal to, because if we were to write this out, the sum of all forces is going to be equal to 0, which is equal to the force of gravity from the planet minus the force of gravity from the moon. So the force of gravity from the planet should equal the force of gravity from the moon. So this is the side that I just wrote. Now we have to do the same thing for the moon. It starts off the same. G, little m, m naught, all over the distance from the moon to that point squared. Well, we know the whole distance here is x. D, and this distance is x. So this distance must be d minus x squared. Well, the mystery mass object, turns out we don't need to know it. That drops. Our G constant drops. And now we have big M over x squared equals little m over d minus x squared. Let's go ahead and cross multiply. Does that make sense? I think so. We'll do that. Big M times d minus x squared equals x squared little m. From here, it's algebra solving for x, but I'll go ahead and work through it. I'll divide by x squared and also divide by big M. So we have d minus x squared. I divided, so x squared equals little m over big M. And this, we can take the square root of the top and bottom. Same thing over here. D minus x over x equals the square root of little m over big M. If we break that up into two separate fractions, d over x and then minus x over x is just minus 1. The square root of m over m. D over x is the square root of e over m. Am I saying e? That should be little m. Plus 1. Do what I write, not what I say. Let's see, multiply by x. We get the square root of this stuff plus this stuff times x. And now we just have to divide it over. So let's see, that's d over 1 plus the square root of little m over big M is x. And if we look, I did that in my head. I think it was the first one when I did it earlier. Yeah, right here. D over 1 plus the square root of little m over big M. Yep, there we go. So awesome. So this, just to summarize, we drew our picture, and then we made a note that the force at this point is 0. Which means the force of gravity from the planet has to be equal to the force of gravity for the moon for those forces to cancel because they're going in opposite directions. And then from there, it was just a little bit of algebra, a little tricky algebra, I guess, but doable. So pretty fun.